Hi, I'm Steve. Welcome back to the Baker's Cave. And today we're going to be doing some prop repair. You may have seen my other video where I replaced the sound. Well, this guy here came in with the other prop. I thought the other prop was going to be the hard one to fix, and I thought this was going to be the easy one to fix. This is a deadlift zombie. He, when activated, will rise up. His head will turn, eyes will light up, and he'll make some sound, obviously. Well, my client brought it in, and he wasn't going up all the way, so I thought this was going to be a mechanical problem with some broken plastic, which is kind of hard to fix. When I dove in more, it wasn't really a mechanical problem. He wasn't going all the way up because the motor was stopping. As I did some more playing around with it, he started to act a little bit more erratically. He wouldn't go up, but the head would turn and the sound would happen. Then the sound disappeared, and then eventually nothing went on at all. So I figured, okay, there's more going on. And right down here in this base, inside that base, there's a motherboard. And when I started to play around with this, I noticed that the motherboard, a couple of the transistors started getting, especially the voltage regulators, started getting really, hellaciously hot. So the motherboard is definitely fried in here. So what we're going to do today is using basically three components: an Arduino Nano, a motor controller, and a real inexpensive sound card. We're going to see if we can get this guy to work, because all his mechanics work. Limit switches, the motors, the gearing, all that works. It's just the electronics that makes them go up and down, and the sound and all that work. So let's go over in detail exactly what this problem is. This is the motherboard. The existing one. Right here is the chip. That's basically like a microcontroller, which we're just going to use an Arduino instead of that. And the other stuff is all for the sound and all, so we'll just get rid of this. And here are essentially the products we are going to use today to get this to work. You're going to use the Arduino Nano as the controller, and it's going to control this motor controller by sending it different inputs. It can make the motor turn one way or the other. In our case, it'll make the zombie go up and down. And this is a real small, simple sound card. So the first thing we really need to do is take this bad boy apart. We need to expose all the mechanics to make them go up and down. We need to see how the limit switches work that tell when it's high, when it's low, and all that good stuff. So that's what we're going to do next. The first thing we have to do is we have to isolate the motor that makes the zombie rise and go down. Here obviously is the motor. Here are the two power leads. They're gray and orange coming off of here. So what I've done is I have cut this connector off of this bundle of wires right here. These two are obviously the power for the motor, and these two are for the sensor up here, the limit switch, to tell the board when the zombie's fully extended. And down here, this is the limit switch that tells the board when the zombie's completely down. I have already cut these off. These went to that bad motherboard. So what we need to do is we need to add some extension for this for these power leads right here. So what I'm going to do is I'm going to add a bit of power cord to these. Now, since we have to change the polarity of this motor from positive to negative and vice versa in order to make the motor either go up or go down, it doesn't really matter which one of these you put to the red or black wire. Zoomed out here real quick because I want to show you something I was using. As you watch some of my videos, you know I'm a big fan of the Ryobi 18 volts battery system. And this is a little battery adapter. Let's see if we can get it to focus. It just slides onto here. It's got a power cord. And I had this little portable soldering iron that can handle anywhere between, I think, 9 volts and 24 volts. This is 18 volts. This is real great for us haunters, because we can actually take this right out to our front yard or wherever and start soldering. We wouldn't need any kind of electric. I'll put a link below to where you can get that. Okay, so now we've soldered in these connections. Now, just to show that we've done this right, here is the power cable coming from the prop's power supply. I put a little adapter on here so we can expose some leads right here. Here is the extension of the motor that we just put on there. And what we'll do is we'll just quickly connect this. And this is going to go one way or the other. Okay, so that works. Now we're going to flip them around. Okay, so now we are able to make the zombie rise and go down. Now the next thing we got to do is we got to make sure these limit switches are actually what we think they are. So we brought over our multimeter. We set it to continuity testing, so that way when two connections are made, we'll get a beep. So these are the two wires from the limit switch up here that tells the board when the zombie's all the way up. So we'll just connect these right here. Now we've got our power again. Let's make sure we're going to make the zombie go up. Okay, so we are. Or actually, that's down. I'm sorry. It's the other way. So what we're going to do is we're going to keep tapping this. And the reason I'm doing this is I don't want to overstress the, I don't want to strip the gears. Okay, so here's the limit switch right up here. So we're getting close. Okay, so as you can hear that sound, let me go the other way so we can get rid of the sound. Okay, so now we have a way of telling the new board we're going to be programming, the Arduino. We can use this limit switch to let it know when the zombie is all the way up. So next thing to do is we're going to test the one all the way down here. And this should be when the zombie's all the way down. Same as before, we're just going to take our continuity lead. Okay, so we bringing our power back. Here we go. Doing it a little at a time. So now the zombie will be all the way down. And as you can hear, you got this tone going off. Let me flip it around the other way so we can stop it. So now we know that this sensor is going to tell us when the zombie's all the way down. So now the next part is we're going to start making the motor work. So we're going to do that using this board I showed you earlier. This is the motor driver, and we're going to wire this up now. Here's the motor controller, and these two terminals. This is the power for the motor that's going to get screwed in there, and this is going to be the ground. We take our power cord we had, and we're going to put the lead in here, put the ground in. So that's going to supply the power for the motors. So I went ahead and hooked up the motor. These are actually the leads for the motor. Now it doesn't matter whether it's positive or negative, because what this board does is it changes the polarity of these terminals to make the motor turn one way or the other. Which in our case, usually it's for a robot for the wheel, so you can go either forward or backward or turn. For our purposes, we either want the motor to make the zombie go up or make the zombie come down. This board has two terminals for motors. Of course, we only need one, so we use the A section right over here. So now we'll hook up the Arduino, and as you can see, it's a very small controller, just perfect for what we want to do. One of the features of this board is that it has a built-in 5-volt regulator. As long as this jumper located at this spot is on, that means that the 5-volt input terminal right here is actually now an output. So whatever voltage you put into here, up to 12 volts, it's going to be regulated to 5 volts to run the board. This will now be a 5-volt output, so we can use this to power our Arduino. The only thing is we have to put in another wire here where the negative is, so we can put the ground onto this. So we're going to use some DuPont connectors here. What I'm going to do is I'm going to cut this end off the DuPont connector, take this and put them in. And we will use our terminals to do that. Take this one back out. We are connecting the ground from the power supply of the prop to one of the DuPont wires that is going to supply the Arduino. Here's this connector. And we're going to look on the Arduino. And these two pins are the voltage in. So now when we fire everything up, this board will now give control to, or give control, will give power to the Arduino. Now there's pins over here that control the motors. You have an enable A, in 1 in, 2 in, a 3 in, a 4 in, and enable B. Okay, so the enable A basically is going to tell the motor to, when it's shorted out like this, it's going to tell the motor to spin at full speed, and you can actually control the motor direction with these two pins right here, which are the signals that'll come from the Arduino. When one pin is high, one pin is low, the motor spins in one direction, and when the other pin is high and the other was low, and one's low, one's high, it spins the other direction. We don't have to worry. This, of course, is for the second motor. We're not going to have to worry about that because we're not using that motor. So we just need to worry about these pins over here. So now we're going to take these two pins and we're going to hook them to the Arduino, and we'll use some DuPont wires to do that. Here are the two DuPont wires that we're going to use for the A terminal, and you got the N1 and N2. So I just used some different colors, and we're going to put these two pins 7 and 8 on the Arduino. We'll put the N1 to D7, and we will put the N2 to D8. And what I'll do is our software will tell these pins whether to go high or low, controlling the direction of the motor and whether or not it's on. Because when both pins are high and both pins are low, the motor shuts off. So at this point, we should have some rudimentary control. So what we'll do is we'll make some simple code to make sure this works. And once we know that the motor control works, what we'll do is we'll then hook up sensor wires right here. Now what we're going to do is we need some code to make all this run. And that's what I'm going to show you. Now I'm going to go over this. This is not going to be a video on how to program an Arduino. But if you have any questions, feel free to let me know in the comments below. First thing here is we are going to set the variable IN1 and IN2 to pins 7 and 8. Those are the two pins that come out from the Arduino that go to the motor control board to make those pins either go high or low, to either make the motor go in one direction or the other, or to stop. Down here under the setup section, we're going to take each one of those pins, IN1 and IN2, and we're going to designate them as output pins, which means they're going to send a signal out from the Arduino into the board. I've made a little function here called stop motor down here, which basically just sets both pins to low, which will stop the motor. So instead of having to type that all the time, I just made a real quick function. And then delay 1000 is delay 1000 milliseconds, or delay 1 second. It's the same thing. 1000 milliseconds is, of course, 1 second. Now down here is the meat of the program. It's the loop. So what we're doing is we are writing out to pin 1 or to IN1 high, IN2 low on the motor board, which will make the motor turn in one direction. We're going to keep the motor running for 1 second. Then we're going to stop the motor. Okay, then we're going to wait 1 second, and then we're going to write out to IN1 and IN2 low and high, which is completely opposite of up here. So the motor will turn in another direction. We'll let that motor run for 1 second, and then we're going to stop the motor, and then we're going to wait 1 second, and then we're going to do that all over again. So basically what that code is going to do, move it up for 1 second, stop, move it down for 1 second. So let's go ahead and see how this is going to work. Plugging the power in. Well, that was certainly a successful test. Now the next thing we need to do is we're going to take the limit switches and we're going to attach them to the Arduino. So now and then we'll change our code. So the shaft will move all the way out until it hits a limit sensor, and then it stops, and then it'll move the shaft all the way up, which would be essentially lowering the zombie, until that limit switch hits. So let's go wire those limit switches up. What I'm basically going to do is, you're going to see a real quick fast forward here. I'm just going to add some wiring here so it can go to the Arduino. I have soldered the limit switches together. 2 of them have to be joined together to go into one, because that'll be going to the negative. And then the other 2, they will be going to the pins on the Arduino to sense when those switches get hit. And I'm trying to figure what pin I'm going to use. Pin 4 and 5. 4 will be the switch for when it's all the way down, and 5 will be for when the switch is, or when the zombie is all the way up. Here is the ground, and we just put that to one of the ground pins on the Arduino. So those are the pins all in there, and like I said, 4 and 5 will be for the limit switches. Now let's put some code in there so it can read these switches. I have wired up the limit switches, and I have changed the code. So here's the code, and one of the things that I wanted to show you that I made a difference of is I made 2 functions, a go up and a go down. Basically what happens when you tell it to go up, the zombie is going to rise up until the limit switch hits is closed, and then it's going to stop the motor. The go down function does the same thing. It's going to lower the zombie until the bottom limit switch is hit, and then it's going to stop the motor. Okay, and then of course you still have this one function up here, which is stop the motor, which when you issue that command, motors are just going to stop. Now here's the loop again, and the loop is really easy for how we're going to test this. I have a lead right here that I'm just going to touch the ground, and that's going to make this work. When the button is hit, it's going to go up, it's going to wait 3 seconds, and then it's going to come back down. So I'm going to hit this as if we're simulating a button push. So here goes, the zombie is rising. We're going to wait 3 seconds. And he's going to come back down. Now we just have to add some sound. I think before we start adding sound, what we're going to do is put his bass back on that we took off so he can actually sit up the way he's supposed to. And then we'll go ahead and start adding some sound. I keep saying we're going to move on to the sound, and I always remember something else. In this particular case, it's the head of the zombie. When he's rising up and making his sound, the head goes from left to right, and the eyes light up. It is controlled by this mechanism here, which when together, it just, through a cam system, it just rotates back and forth. There are 2 plugs. I have some plugs in them right now because I did some experimenting off camera, but they plug into 2 holes that are in the top of the body right here. So this is what that spinning mechanism looks like. This cable here goes and lights up the eyes. Here's the cam system right here, the motor. Okay, spins, and this cam goes back and forth against one of the pegs on here. So basically what happens, even though the motor is turning 360 degrees, due to the cam system, this is just rotating, clockwise, counterclockwise. I wasn't quite sure how this tied in with the existing motherboard, but the 2 plugs that plug into the top of the zombie, they're 3.5 millimeter like power barrel jacks. I've just simply rewired them. One is for the sensor that's right here. I don't know what the sensor would be for, but I'm using it as a homing, like a homing switch. So when the zombie goes down and is at rest, the head is facing forward. This will tell me exactly when that is. The other one I'm using for power. Okay, so obviously a positive, negative, and it's going to this little 3.3 volt regulator right here. That's feeding the LEDs because, the voltage coming up into here is going to be about 6-7 volts. That's going to be too much for the LEDs, so I put a little tiny 3.3 volt voltage regulator on here. Now this whole motor turns in only one direction, unlike the body lifter where the motor has to turn one direction to go up and another direction to go down. Ended up what I'm going to be doing, even though I had this as a test, I'm going to tie the motor into that other port that's on that motor that's in the base. If you recall, we put a motor controller in the base here to control to go up and down, and had room for to control two motors. Originally, I thought we were only going to need one, for obviously going up and down, but we're going to use the other one to control the motion of the head. So the power for that motor comes up into here. It's only going to be going in one direction. So this connector here is always going to be positive. This is always going to be negative, which is what I need so it can run this voltage regulator. This voltage regulator, has a fixed, positive, negative. So we're only going to be turning this one way. Let me put this all together and I'll show you exactly how it works. I've got a little test script on the on an Arduino that I'm using just to test this mechanism. So run that right now. What you're going to see is this is going to rotate back and forth for about 3 seconds, and then it's going to find its home position. See, and it stopped and found the home position. Now let me see if I can get you the head in here too. So I'm going to reset the Arduino again, and you'll see how this is going to find the home position after it spins for 3 seconds. And it came right back to the same position again. So now what we have to do is just simply glue this back onto here. We have his head on, and let me show you exactly how the head connects to here so you know how we wired it. So the head is made to be taken off for storage. So it pops off, and there are two male 3.5 millimeter power jacks in here, and on the underside of the head there are the female jacks, and one provides the power for the motor and the other one is the sensor, so we know when the head is facing forward. Put the head back on there. So I've ran those connections from those 3.5 millimeter plugs all down into here and wired them into our test motor controller in Arduino just so we can test it. So we'll do that now, and the eye should light up. The head will turn about 3 times and then end up facing forward. There you go. It works perfect. The only thing I may want to do is change the speed of the motor so the head turns a little bit slower. So now what we'll do is we will wire all that into the Arduino that's actually in him, and we'll change that script around so he'll rise and the head will turn at the same time. So that's what I'm going to do next, is I'm going to wire that in. Now let's talk real quick about the sound card we're going to be using that's going to drive the sound. Here is a tiny little sound card. Here it is, just the card. What's nice about this board is even though it's tiny, it's packed with a lot of features. One of the most impressive ones is a 3-watt amplifier, so you can power a 3-watt speaker. Now, the pins are 5 volts to power it. The DAC left and DAC right are for sound going out to like an amplifier, like computer speakers. The busy signal, that goes high. Actually, it's always high. It goes low when a song is playing. That's for you to figure out whether or not the sound is still playing or not. The RX and TX pins are the transmit and receive pins that you would use to attach it to an Arduino. The ground is where your negative from the power supply is going. And the bottom two are mono sound out. The speaker left, or not the speaker left and right, the speaker positive or the speaker negative. The P01 pin, you can short that to ground and it will play the first file on the sound card. So you could literally use this card in a standalone feature, hooked up to either a relay or a button. The board also includes a micro USB port, so you can easily attach it to your computer to download the sound files to the board. Now here's a look at the base of the zombie. With all the components. I know it looks like a mess, but it's really not that bad. In the lower left, we have the Arduino, and I'll give a description of what each one of these wires does. Over here is behind all these wires is where we have the sound card, and up top here is the motor controller. So let's delve a little deeper into what the Arduino is controlling, or rather what the wires do. So here we have the Arduino Nano that we're using. It's one of the smallest boards you can get for Arduino, which makes it perfect for putting into props. The first thing we have connected are the power inputs for the Arduino, which are coming from the 5-volt output on the motor controller and the ground from the motor controller. That ground gets tied into everything, the sound card, the lights, the Arduino, everything. Next, we have the power going out of the Arduino that's going to the sound card to obviously power the sound card. Next, we have the transmit and receive pins for the sound card. Pin 12 goes to the transmit pin on the sound card, and pin 11 goes to the receive pin on the sound card. And next we have a controller for the motor A, which is the motor that makes the zombie go up and down. Pins 3 and 4 control the direction that the motor goes in, and pin number 10 basically enables or shuts the motor on or off. And these are the same kind of pin controls for motor B, which is the head control. Pins 3 and 4 control whether the motor goes forward or backwards. Doesn't really matter because it's on a cam system, so it doesn't matter which direction the motor goes in. And pin number 5 controls whether that motor is on or off. Pin number 9 is connected to the bottom limit switch, so we know when the zombie is completely down. And pin 8 goes to the top limit switch, so we know when the zombie has completely risen. And then pin 2 is the switch that's in the head that lets me know when the head is pointing straight ahead. A1, which is the analog input, but we're using as a digital input. That is going to read the signal coming from the sound card. It's going to go low whenever a sound file is playing. That way we know when sound is coming out of the card or not. And the A5 pin, which also is being used as a digital output, that powers the LED eyes, so the eyes go on when everything starts up. Now let's take a look at the base of the zombie. Here's the base with the bottom cover all together. And on the top of the base, you're going to notice two things. One is a switch, and that simply turns the internal speaker on or off. And I'll show you why in a second you want to be able to do that. And then, of course, the other, the silver jack there, that is for the power, where a 9-volt power supply goes in. On the one side of the base, you have two wires coming out. One is a USB extension cable that goes to the Arduino. This is so if the end user wants to make some changes or reprogram the zombie, he can easily hook up the Nano to a computer and do that. The other wire coming out is for PIR sensor or motion sensor. Here it is in its case. And I'll explain that connector you see attached to it. Usually I just hardwire it back in, but I did something a little different with this one. Instead of just hardwiring it straight back to the Arduino, I put this 3-conductive pin, which is basically like an audio conductor. It's got a tip, ring, and sleeve, and as you see the 3 connectors right there. And what that allows the end user to do is to take a standard audio extension cable and move the motion sensor, as far as he wants from the prop. Moving to the other side of the base, there's 2 more wires. One is, again, another USB extension, and this goes to the sound card. So if the end user wants to change the sounds on the prop year to year, he can easily do that without opening up the base. And the other one is the external audio jack, which would go to a set of powered speakers, like a set of computer speakers to give more robust and a louder sound. And you could also move the speakers away from the zombie as well. And of course, if you use that feature, that's why we have the switch for the internal speaker. If you're using the external speakers, you would just simply flip that switch and turn off the internal speaker that's in the base. So I'm not going to get too far down into the weeds with the programming of the zombie. We can do that in another video if you'd like. Let me know in the comments below. But here is a flowchart of the functions that make the zombie work. The Arduino powers on the Nano, and it does some initialization first. First, it lowers the zombie. Then it centers the head. And then it starts a loop. And what it's doing is it's constantly looking for motion from the motion sensor. Once the sensor detects any kind of motion, it starts the zombie to rise. It also starts the sound that accompanies the rising of the zombie. And then we go into another loop waiting for the top limit switch to be hit, so we know when the zombie's at his raised all the way up. So once that happens, we stop the zombie rising, we shut the motor off, we stop the sound that was occurring with the rise, and now we start a second sound file that accompanies the head moving. And of course we start the head motor, and we turn on the eyes, and then we go into another loop, and we're looking for that busy pin from the sound card. So when the head sound stops, the Arduino will know, and it goes over to here, and at that point it stops the head motor, it centers the head, and then it lowers the zombie. It goes into another loop waiting for the zombie limit switch at the bottom to be hit, so we know when the zombie's all the way down. And once that happens, it stops the motor, lowering the zombie. And then we just wait 5 seconds before any kind of activation can occur. And then it just goes back into a loop again, waiting for some more motion. So here he is, all assembled, put together. I got the motion sensor over there. We went over the programming of the Arduino. Again, if you're trying to repair a prop and you want to use an Arduino, don't be afraid by what I did here. It's very, very easy. I'm thinking about putting a video out in the future showing people how to use some of the simple things we did here with LEDs and motor controls. But another video, another time. Like I said, the main purpose of this video was just to show you that just because you have a prop that doesn't work, doesn't mean you need to throw it in the trash. You can, with some simple parts, you can get it to work again, and you can even get it to work better than before. The motion sensor is a little bit better on here than it was before. The sound is much better than it was before, as you'll see in a second when we demonstrate how it goes up and down. Why don't we just go ahead and do that right now? So I'm going to go over here to the motion sensor, wave my hand in front of it. Now, he doesn't make that much noise going up and down. The microphone is literally right in front of him, so that may have made that sound a little bit louder than what it was. But as you can tell, the sound was much better than when, well, actually, you couldn't tell because he was broken. But it's much better than it was before. The other nice thing about using the Arduino and the sound card is you can change the programming. You can make this very intricate. I mean, you could make him go up so far, say something, go up again, say something else. On the other hand, it's real simple to change the sounds without even changing any of the up and down code. The end user can just put 2 different sound files on the sound card, so each area can have different sounds going on, one for when he rises and one for when the head turns. Yep, he's all fixed. He's ready to go for the next haunt coming up. We are now on the wrong side of Halloween. It's coming quick, so we've got some more builds coming on. I've still have been promising you guys how we're going to take the Sinister doll back there, and we're going to put some animatronics into that. The next video I think I'm going to be doing is with some more sound. I've gotten a lot of requests for how to do some external speakers. One of the things about this guy when we redid him is we had the ability to output sound to some amplified speakers, but people have been asking how can I weatherproof that. I'm going to show you how you can make a nice weatherproof, or at least weatherproof or at least weather resistant speaker for outside with a real good amplifier for, a couple dollars. And I think that is about it. I think that's it. If you have any questions at all, just put them in the comments below. I'll put a link to any of the supplies and tools that I used here today. And until the next build or repair, I'm Steve. Thanks for stopping by the Maker's Cave.